Hello all. In this video we will talk about kernel execution time and kernel fusion in a SQL code. So these are the two very important topics when you are building a POC for hack to skill challenge, as well as you are building something new on SQL, because SQL is very much new. I thought of exploring these two ideas a lot. So for a code that you are building, you want to find out how much time does it take to for the entire code to run. For that, what you need to do is you have to declare two objects, one start and an end object, for finding the time duration. Okay, now you have to record the time duration before the kernel executes and after the kernel has stopped execution, with the help of a particular function, that is std chrono high resolution clock now, that allows us to measure the time immediately before and after the execution of the kernel itself. Now with that in mind, I also present kernel fusion that I have recently discovered while coding, and it's very useful because kernel fusion allows us for reducing the overhead that's there in the code itself with changes. Okay, so it helps us in a very useful way, because in that case the execution time for the code is much more lesser. Okay, so the basic idea is to combine two or more kernels into a single kernel to reduce the overhead of launching multiple kernels and to reduce memory bandwidth usage. So we'll see the same thing in a demo right now. So first of all, you see I have used a fused kernel over here. So using fused kernel for a parallel for loop for a molecular dynamics example that I am performing, what it does is that if you see the time needed to run the program or the entire loop, it's 590 microseconds, but without the help of without running the fused kernel that I have already used in the past code, you'll see the change. So the same code, when I am not using fused kernel, it gives me a timestamp of see, that's the change. So it's much more slower over here, and here for this particular purpose of code, I will show one particular point that I have used two kernels for this. So first of all, when I started using the kernel itself for the parallel for loop, at the top here I used a force kernel for here, and after that there is an update kernel in the next submit queue when you are using this update kernel itself. But to combine both of the kernels together, I have used fused kernel at the top for the previous code. It's the same code that you see, but using the instance of kernel is different. I have used fused kernel in the previous code, but not in the second itself. So when I am using the fused kernel, I am just showing the portion of it. Here I am using the fused kernel, and with that also the time duration changes, or the execution time is much more faster using fused kernel. Okay, so as I mentioned about the timestamps, so for using the timestamp, what you need to do is first, as per the discussion of the slide that you have seen, we use the function high resolution clock with start and end timestamp with double duration, and again here you start the timer before the kernel starts execution, and after the end of the kernel execution you have to again call this end timer, and after that we collect the timestamp and print it. So with that you can see how the program behaves for the work you have done, and it's very usable, and it becomes a very high scoring point in terms of your POC for the final hack to skill presentation. And this would be, I guess, very useful for you too. So just focus on my YouTube channel that I am presenting. I will be showing much more work on SQL itself, so that you get acquainted with the language, and more on OneAPI AI Analytics Toolkit too. So stay tuned and register for my channel. Thank you.